Hey guys, this is Srini and you're watching Python tutorial videos on my YouTube channel, Python for Microscopists. In the last couple of, in fact, I should say in the last 3 to 4 videos, we talked about Pandas library, which is an incredible library in Python for data handling, data analysis, which is quite common in whether you're in research or quality control at an industry. It doesn't matter. We always deal with data and we often end up using Excel. And we talked about how Pandas can give you more power in terms of manipulating your data. I'm not saying cheating with your data. When I say manipulating, handling the data, rearranging columns, filling in missing data, in a meaningful way, and so on. Now, eventually, what do you want to do with all of that, right? I mean, once you have all this data, you're trying to extract information. And oftentimes, the easiest way to represent or convey the information contained within this data is by plotting. And that's probably why Pandas actually included a few core functionality, when it comes to plotting. And they're just borrowing this functionality from Matplotlib, which works in the background when you're using the plotting functions from within Pandas. So in today's tutorial, let's actually go through a few of these core basic functions. And again, I cannot show you every little detail of plotting. You can always go to the documentation online and get more information. I just want to make sure I introduce the core plotting functions within Pandas so you can explore it further. And before jumping in, let's actually look at the example CSV file that we are using for this tutorial. And I talked about this example file in the last couple of tutorials anyway. So this is a data set where we captured the total number of cells counted in each image. So there are 25 images in each set. I have set 1 here with 25 images, and then set 2, set 3, and set 4. So total I have 100 images, and each image has been analyzed manually. Well, this person actually skipped some of these images because they overlooked these images. But most images, they were analyzed manually, and then we have a number of cells that this person counted in each image. And then another person also tried to count and gave up after the first 3 images. Pretty smart person, I should say, because he thought that his time is better spent doing research and not doing manual counting of cells, which I totally agree with. And the next 3 columns are the cell, where the cells were counted in an automated way using a Python program where we have written code to perform watershed-based segmentation and with subsequent counting of cells. And what's the difference between these 3? I changed the threshold value a little bit between these 3. And I bet if I can optimize this a little further, I could have actually matched very closely with the manual counting. I should mention even the manual is not perfect, right? Even with the 3 images, this is pretty close, but these images, you see there is a difference of 7 or so cells between these 2. So even manual counting is subjective to some sort of uncertainty. So anyway, by changing the threshold, we could have actually fitted the data better with manual. So we could have actually used that value going forward. Anyway, that's beyond the scope of this tutorial for now. So let's understand the data set and jump into our Anaconda Spider IDE. And again, the reason I'm using this IDE is because it comes with all the libraries that I'm using pre-installed: Pandas, Matplotlib, scikit-image, and so on. So step number 1, import Pandas as PD, because we're going to use Pandas library. Step number 2, define our data frame, which is nothing but what is our data set, right? So define our data frame as pd.read_CSV. Okay, experiment with others, but I'm going to work with CSV file. And what is the name of my CSV file, or the location of the CSV? So this is called manual versus auto.csv. And there you go. And just a sanity check, let's go ahead and print df.head to make sure we are reading it correctly and we are, at least understanding exactly how the data frame looks like. So this is the data frame that we are looking at, that Pandas defined after reading the CSV file. So the first column is the index that it automatically assigned. It goes from 0 through whatever. And that index can be changed you can use one of the columns, existing columns, as the index, as long as you have a unique ID. Otherwise it's obviously very confusing. It doesn't make sense to use an index there where you have the same data multiple times. Okay, the next column, because we did not have any title, in the first cell, it gave a title by default. It called it unnamed 0. And the other ones, we got some names, and then wherever there is missing data, it actually filled it with NaN, not a number. And in the last tutorial, we looked at how to deal with not a numbers. Okay, so for this tutorial, let's focus on manual and maybe also auto threshold too, if we have to plot them, on the same plot. So let's jump in. So how do we plot? Okay. So we're not importing Matplotlib. The intention of this tutorial is to use whatever is built in to Pandas. So it's as easy as df. What do I want to plot within my data frame? I want to plot the column manual and then plot. That's it. If I go ahead and run it, you'll see the plot right there. Okay, so that's the default plot, which seems to be a line plot. If you don't like that, go ahead and tell that you don't want it. Okay, so the plot kind equals to HIST. Okay, so this tells exactly the type of plot, and by default I believe it uses 100 bins or something, or 10 bins. But anyway, because I don't know how many bins it's using, I can actually define it. So instead of that, let's actually do bins in addition to histogram. Bins equal to 30, for example. Okay, so there you go. So that's 30 bins. If you want to assign a title, you can actually say this is manual count. Okay, I always make this mistake. Okay, let's go. And then it should give it a title. It's called manual count. And if you think the image is too small, I promise this is the last thing I'll show as part of the parameters you can define within this plot. There is a lot more that you can do. Again, look at the documentation. So if the figure is too small, you can just say fig size equals to, what would be a good one, 12 by 10. I believe the units are in inches, but you should see a large plot by now. Okay, so this is a quick start to how to plot. Now, oftentimes, let's say we don't want to plot this entire thing, so let's keep that as is. I just want to, let's say, let me open Excel or the CSV file. So let's say we just want to plot set 1 and ignore set 2 completely. Okay, I'll also get into later on, how to plot all of these, set 1 versus set 2, set 3, and set 4. But let's take one thing at a time. So how do we separate set 1? In again, our Pandas tutorial, I talked about how to slice your data frame to get only set 1 or to get a subset of your rows. So that's exactly what we're going to use right now. So I'm going to just say, first of all, actually, I do not like the name. Where was it? If we go back, I don't like the name unnamed 0. It's not intuitive. So let's actually change that. Okay, a slight detour, but we already covered that in the previous tutorial. So I'll include a few elements that we learned in the previous tutorial in here. So again, we refresh our memories every time we do this. So the way we do that is df. I thought for a second there because I was thinking whether I should create a new data frame, but let's not worry about that. Let's actually update the existing data frame with the new name. Okay, so df.rename, and what do you rename? Columns equal to, yeah, and columns equal to, what's the name? It's unnamed 0. So let's unnamed 0. Okay. Yeah, and to what? So let's call this image set. Okay, so let's call this column image set. So all I'm doing right now is changing the name. Okay, so print head. So you can see, what did I do here? Oh, let's print this, and there you go. So our column unnamed 0 has been renamed to image set. Okay, a slight detour because I don't like the name unnamed 0. Now that we have renamed it to image set, it's a bit more intuitive, right? So now how do we extract only set1? So we know, let me create a new data frame. So I want to call the set1 data frame is equals to our existing data frame, okay, and of which I want the data frame from the column image, what did we call it, set, okay, where all values are equal to set1, okay, where all values are equal to set1. I think this should work. My set1 data frame is a new data frame. I'm sorry, just doing a sanity check. Image set equals to set1. This should work. Print df dot, not df, set1 underscore df, okay, dot head. So we can just, actually let's look at the tail, because the head is always set1. The tail contains the last few entries, last few rows. So let's just look at the tail. You see the last 5 are just set1, so we know that that worked very, very well. Okay, so now we just need to plot. So to plot, instead of df, I just want to do set1 underscore the new data frame. This is what I want to plot, and let me go ahead and run this whole thing. So this new plot is nothing but a plot of this new data frame. Okay. So that's pretty much it. So you can slice your data just like we've talked about in when we covered the Pandas basics, and then bring that information here and then just do dot plot. That's it. And within dot plot, you can define the different kinds of plots, and we'll talk about a few others in a minute. Okay, let me delete this and let's go back to our data frame, and let's actually delete all of this and keep things simple. Okay, dot plot, and again, what did this do? It just plots our entire data. Now let's do one more thing, because this is too jumpy. Let's say if you want to smooth this, all you need to do is I'm thinking like which way to actually smooth this. We can actually do a rolling average. Okay, you know how you can do a rolling average? You can actually do when I say rolling average, rolling mean, for example, you can do a rolling sum of so the way to define that is, let's still stick with manual, but now let's just say rolling 3 points. Okay, and what do we want to do once we roll 3 points? We want to do a mean. Okay, and then plot. I think this should actually do. If I plot it, there you go. So it's actually averaging every 3 points, okay, on a rolling basis, and that's where the plot is. I believe the gaps are coming from the missing data that we have. So if we actually filled the missing data with some values, that probably would have looked a lot nicer. But anyway, this is the way to do your rolling, averaging. Now let me look at my notes about what I should be covering or what I intend to cover here. Yeah, this is a good one. There are a few topics I wanted to cover, and depending on the length of the video, it's only 14 minutes into it, so we should go ahead and cover this other one. Let me leave the first 3 lines as is. So now let's actually graphically represent the statistics. Like if you remember, I think we did df, which one? Let's look at the manual column again. And if you extract the manual column and then just do describe, okay? So if you do this, let's go ahead. Sorry, we should print it. Okay, so when you do this, it actually prints out, the total number that we have, the mean value, the standard deviation, the minimum, maximum, 25th percentile, 50 percentile, 75 percentile. All of this can be graphically represented. Obviously, how we do that using a box plot, right? So how do we do the box plot? Again, as you can imagine, this is nothing but the kind equals to box. That's it. So let me copy and paste from my notes that I have here, and you can look at that. So again, we are plotting dot plot. Instead of histogram, I just typed box and then the figure size 8 by 6. Yeah. So let's go ahead and run this. And there is the box plot. Again, not great data to look at, but you can see where the mean is somewhere around 100. And I believe these two are the 25th percentile. We can check that, 95. There should be a line right there. Where is it? Like 108. Yeah, I think this is 75th percentile, and the 90 right down here, that is the 25th percentile down here. And then these are your maximum value 120, and I believe this is the maximum minimum, which is 80. So you can actually represent this. Again, if you have better data, that would have made much better sense. But okay. So this is again, we looked at the single column. So, but if you want to do like a couple of columns, again, this is nothing but a line plot, right? So df dot instead of manual, let's just do df dot plot. Let me erase everything and start from scratch. Okay, df dot plot, and what the kind of plot we want to plot right now? Let's plot a scatter plot. Okay. And then you can define, I'm a bit curious what happens if I do this. Yeah, it requires, you see, it requires X and Y column, right? So now we need to define, because it is a scatter plot, now let's define what X is. X is our column called manual, and Y is our column called, what did I call it? Auto th underscore 2. That should do. So let's plot this X and Y. So this is, again, not interesting data, but again, you can imagine. So this is my X, which is nothing but the manual count, and we are basically plotting manual versus auto count. That's it. Nothing more than that. And again, we talked about you can do your title equals to manual versus auto 2 or something, right? So you can give it a title, and again, there you go, manual versus auto 2. Okay, so this is, again, there are various kinds of plots that you can actually plot, so go ahead and explore those. Now, before ending this tutorial, it's only 18 minutes, let me take a few more minutes to actually talk about where you can actually use functions, for example, to create some sort of a category. Let's say let's go through an exercise. For example, let's go open this image and say any count that is below 100, let's say that's a low count of cells. Any count that's above 100, let's say that's high count. So let's write a function where it adds a new column here called category, for example, or image category, I mean, whatever. It gives a title, and then it fills it with a value of low or high based on, let's just stick with manual, okay? So that value here would be low because it's 92, it's below 100. So how do we do that? Again, so imported, renamed image set. Okay, so that part is fine. Now let's define a function. How do we define a function? You know that, right? So def, and let's call this, the function name is, I don't know, let's just call this cell count, for example, and with one variable. So now cell count X. Now I'm going to say X is nothing but our cell count, the count that it goes through when it's going through each cell over there. So I'm saying if X is less than or equal to, let's stick with 100, okay? I don't know, are these numbers? We can just type 100 point, okay? If X is less than or equal to 100, okay? What do we want to do if X is less than 100? Let's return, okay, low. Else, what do we want to return? If X is obviously greater than 100, let's return high. All I did is created a function, okay? Let's understand this. all I did so far, nothing different than I'm not messing with the columns or anything yet. All I did is just defined a function saying that if x is less than 100, it is low. If x is greater than 100, it is high. That's pretty much it. Now we need to figure out why is this. Oh, I hate this. Let me make sure everything looks okay here, because apparently I didn't check. Okay, there you go. One back and then one back, and we should be fine. Okay. Now we want to send the entire manual column, okay, through this function, and then hit an apply. Okay, we want apply. Again, I'll show that in a second, but we want to send the entire manual column through this function and then label that as either a low or high. And how do we do that? And so the way we do that is go back to our data frame, right? So in our data frame, create a new column called cell, I don't know, count index, let's say, or yeah, that's a good name. I'm not feeling very creative right now, so let's just call cell count index. So this is a new column that we are adding, and how do we want to fill the values within that column? So look at the manual, okay? Dot apply. What do you want to apply? We want to apply a function called cell count. Okay. I hope this makes sense. And let's see. Yeah, it's not yelling at me, so I think I got everything right. So all it's doing is it's actually taking the cell count. Our data frame. It's adding a new data frame, and then how is that value filled? Well, it looks at the manual column, and then it applies cell count, meaning it applies this function. Okay. Before moving on, let's go ahead and see if df.head, if it actually did what we expect it to do. Okay, there you go. And this is something I haven't done before, and I had to do a little bit of research before this tutorial, because I thought, okay, why not? This is a great use case for this specific data set, so why not go ahead and research it a little bit, and I'm proud of myself, obviously, for finding this out. But if you're a great, strong programmer, you probably know this by now. Anyway, so it seems to have done the trick there, right? So we have 92 here, and cell count index is low. We have 104 here, the cell count index is high. Yeah. So this is how, again, you can manipulate your data frames, but it's not fun to stop right here because we have it. Let's go ahead and plot. Let's go ahead and plot these different categories. Now we created a category called cell count index, low and high. And how do we plot this? And first of all, even before plotting, if you want to save this to df.to underscore cs, is it underscore csv? Yeah. Let's go to df.to csv and just say manual versus auto 2.csv. Again, I'm not very feeling creative right now. So now you can actually dump this new data frame into a new CSV file. Let me see if it updates here. Yeah, and let me open this so you can see how the new column has been added. It's very slow. Okay, there you go. So, okay, now there you go. So the new column right there, low, low, high, and it seems to look pretty good. Okay, so this is how you add a new data column, and let's leave that to save it. Now let's go ahead and plot it. Okay, so let's plot the low versus high ones. Okay, so what should we do? Let's actually not print. Let's I'm thinking, what's the best way? Dot box plot, I think, and then which column do we want to print? Column equals to, sorry, I'm losing my sight. I should probably wear my glasses, but anyway, column equals to manual. And the trick is, how do you want to sort them? How do you want to plot it? By. Okay, so when you say by, this is cell count index. This should do the trick. Okay, now let's go ahead and plot it. So all we're doing is just permission denied. Oh, I have that file open. Let's just comment this. Let's go ahead and run. There you go. It's not very clear, I guess. I can actually print a larger plot, but you can actually see this is the box plot individually for all that fit in a category of high. And there's a reason why I wanted to leave this open, this Excel, so you can see. So all this is doing is it's actually taking this column and actually sorting the data based on low and high, and then just doing a box plot for each of this. We know that for the low, the below 100, the value, the highest value is 100. So you can see the highest value there. The lowest value is 80, and this is how the data is spread. And the exact opposite here. The highest value is the lowest value for the high one is 101, and then it goes to 120 apparently, and here is how the data is distributed. I hope this makes sense. I hope I didn't confuse any of you, but then this is a scenario where you'll probably find yourself, okay, you have a grain, let's say you're trying to analyze an image that has a bunch of grains. And the image is, let's say the grain distribution is bimodal, meaning you have a set of grains that are large, a set of grains that are small because they're fitting in between these large grains. And you want to understand the size distribution between these two, because you may not get the right information if you plot all in one plot. Yeah, so you can separate them as large grains and small grains, and then just look at the distribution of the large and the small ones. That's probably an example I can think of right off the top of my head. But anyway, I hope you found this tutorial to be useful. But in the next tutorial, I'm going to talk about another amazing library called Seaborn that has a lot of functions. Well, again, it's used for plotting, but then it takes plotting to the next level. Again, it also uses Matplotlib in the background, but it takes it to the next level. And I hope you'll join me for that tutorial. And if you like this video, please do not forget to like it. And if you like the content I'm covering in the videos, please do subscribe. I get very encouraged by every time I see more subscribers. We are all humans. We get encouraged by the feedback that we actually get, whether it is critical or positive feedback. Getting feedback is pretty encouraging. Anyway, thanks a lot for your attention, and let us meet again in the next tutorial.